Okay, welcome to this video in our clinical reasoning series. And here we're going to talk about sensitivity, specificity, and predictive values. These are characteristics of a test. And so if we were to look at our schema here for clinical reasoning, it's going to be used in prioritizing your differential diagnosis when you're going to be evaluating the diagnoses on your differential. And we're going to talk a little bit more about how to do that in an upcoming video. But right now, you have to know about these characteristics. And you probably have learned about these in your evidence-based medicine or biostatistics course as well. And I'll put some links in the video that have some more intuitive discussions about sensitivity, specificity, and the predictive values. It's a little bit tricky to get an intuitive understanding for it, so don't worry if you don't get it immediately. It takes a while, but let's go through this. Okay, and so here we have what we're going to learn. We're going to learn about these things: sensitivity, specificity, and the various predictive values. And this is the common 2x2 table that you're going to see. It's called a 2x2 contingency table, and it has all these values in it. And we're going to go through this step by step. So we're going to build this table ourselves throughout this video. Okay, and so first let's talk about a disease. Okay, so we have 10 people here, okay, and we don't know who has a disease and who doesn't have a disease, but actually some of them do, and actually, as you can see, 4 of them here do have the disease, and they have orange heads. And if you can remember from your EBM class, the prevalence of disease is like the percentage of the population that has that disease, and so in this case, we have 4 people out of 10, so the prevalence of disease in this population, or in this sample, is 40%. All right, and we also have a test, and the test can be positive or negative, and we're going to apply this test to this sample here, okay, and we get values. And if we have a perfect test, every time the test is negative, the patient does not have the disease. Every time the test is positive, the patient does have the disease. Remember, we don't know if they have the disease or not. The only thing we know is the results of this test, and the reason we do the test is so we can make some kind of judgment on whether the patient has a disease or not. But there is no such thing as a perfect test in the real world. Sometimes when the test is positive, they actually don't have the disease, and sometimes when the test is negative, they actually do have the disease. And we want to quantify that, like how often is a test wrong or how often is a test right. And that's what this is about. That's what this sensitivity and specificity and predictive values are about. There's no such thing as a perfect test, and these values are all going to be percentages, so 0 to 100. So there's no perfectly bad test. You're not going to get a test that's always wrong, and so have a 0% sensitivity, specificity. And you're not going to have a test that's always right and have 100%. All right, and so now let's look at these. All right, so of all the people who have the disease, when did the test get it right? Right? In this case, and here. So when the test was positive, they actually had the disease, and these are called the true positives when we got it right. We can get it right in another way, right? If the test was negative, the patient didn't have the disease. So in these cases here, so these are another way we can get it right. So when the test was negative, it truly was negative. It represented the truth of negativity because this patient didn't have the disease. Now there are 2 ways we can get it wrong as well, right? You can have a negative test, and the patient actually has the disease. So the negative test is supposed to mean they don't have the disease, but that's not correct. That's not what really is represented here. And so this is a false negative. The test was negative, but falsely so. And we can have false positives. Similarly, the test was positive, right? And so we would expect the patient to have the disease in this case, but this person didn't. So we have a false positive. So again, no perfect test. We would like it for the most of the time to be correct, but there are going to be some times when it's wrong, and we want to quantify that. So these are the different qualities, or that we're going to try to measure in this test, right? Or quantities, actually. How often is it right and how often is it wrong? And so now we're going to build this 2x2 table. But first, let's explain how we typically set it up. So along this column here on the left side, we're typically going to put the test results. And the test is either going to be positive or negative. So for the most part, this is what we're going to see here: test positive and test negative. And then we're going to put the state of reality, or what we call the gold standard, which is the best understanding we have of how things really are. And so in this case, what we're testing for is whether the patient has a disease or whether the patient is healthy. Right? And so whenever we're right, what do we have? These are the 2 things we have when we're right: true positive and true negatives. We just talked about that. So when the test is positive and they have the disease, true positive. When the test is negative and they don't have the disease, they're healthy, true negative. And we also have two ways to be wrong, right? The false negative and the false positive. So here, if a test is negative and they do have the disease, then that's a false negative, right? And if the test is positive, so we would expect them to have the disease, right? But they don't have the disease, that is a false positive. So those are the two ways that we are wrong. So we can sum up all the number of times this test is positive, right? So that's the times we were right when the test was positive, and that's the time that we were wrong when the test was positive. So true positive plus false positive equals all positives. Similarly for the negatives, right? We can sum it up. We can say all the times we were right when the test was negative and all the times we were wrong when the tests were negative. So all negative. We can also add up all the people with the disease. Again, we can say, here are the people who had the disease with the positive test, and here are the people who had the disease with a negative test. And this is all the disease patients. And here are all the people who don't have the disease with a negative test, and all the people who don't have the disease with a positive test. And so add those up. In this column, you have all the healthy people. All right. Got it? Now we're going to move on. We're going to talk about these values. So we can now ask, how often does a positive test pick up patients with the disease? So in all the patients that have the disease, how often is the positive test right? Right? And this is what's called the sensitivity of picking up a disease. So in all the patients with the disease, how often is the positive test right? So we can say, put all the patients with the disease in the denominator and true positives in the numerator, and that is going to be what we call sensitivity. And now specificity is kind of just the opposite of that, right? We can say, of all the people without the disease, how often is a negative test correct? Yeah? And so that's called the specificity. So how specific is a test at isolating a disease? So you can guess it, right? We're going to put all the healthy people in the denominator, and then we're going to put the true negatives here, right? And so now true negatives over all healthy is going to tell us, of all the healthy people, how often are we correct with it saying that it's negative, and that's the true negatives. Now we can look at it a different way. We could say, how often is a diseased person picked up by a positive test? And this is called the positive predictive value. When a test is positive, how often does it predict diseases? This is different than what we were saying with sensitivity and specificity, and you'll see when I draw it out that we're now going across the rows, right? So in all positive tests, right, how often was it correct? Right? How often did it predict that someone had the disease? And so we would say all positives in the denominator and true positives in the numerator, right? Okay, now let's look at the next one. And this is called the negative predictive value. In all patients who had a negative test, how often did this test correctly predict that they don't have the disease? All right, and that's called the negative predictive value. So in all patients who had a negative test, how often was that test correct in telling us in predicting that they don't have the disease, right? And so all negatives over true negatives. And that's the negative predictive value. And so let's put some numbers in here. Let's take a look at the ones that we had done before, right? This is our little sample we had before. And we know that we had 3 true positives and 4 false negatives. And we had 1 false negative, right? So here's a negative that was we had, but falsely so because this person actually had the disease. They were not disease-free. And we had 2 false positive. So here's 2 positives, right? And we would expect them to have the disease, but nope, they were disease-free. So this was falsely so. So we have 2 false positives. So now let's calculate all of our parameters here. So of course, first we can say how many times was the test positive? It was correctly positive 3 times and incorrectly positive twice, so all positives was 5. How many times was the test negative? It was correctly negative once and incorrectly negative once, correctly negative 4 times and incorrectly negative once, so for a total of 5. And how many people had the disease, right? So we have that here. We have 3 people that we picked up with the test and 1 we didn't pick up with the test, so 4. And how many people were healthy? We had 4 people that we picked up with the test and 2 people that we did not pick up with the test that were healthy, so 6. Okay, let's take a look now at sensitivity and specificity. And remember, for these, I like to think of these as going down in the columns. All right, so sensitivity, let's look at that first. So we're saying of all the people with the disease, how many of them had a positive test? right? So of all the people with a disease, that's 4. How many had a positive test? That's 3. So 3 over 4 equals 75%. Now let's do specificity. Of all the healthy people, how many had a negative test? Of all the healthy people, so 6 goes in the denominator, how many had a negative test? 4. So 4 over 6 equals 66%. Let's look at the predictive values. Now, those go across the rows, right? So before we were talking of all the people without the disease, now we're going to talk about of all the people with a positive test. Of all the positive tests, not of all the people with a positive test. Let's just say of all the people with a positive test, how many times did that test correctly predict that the patient had a disease, right? How often was it correctly predicting? And so of all the people with a positive test was 5, and then how often did it correctly predict? 3 times it correctly predicted, so 3 over 5 is 60. And now the negative predictive value. How good is the negative value at predicting? So of all the people with a negative test, so that's all of these, how often were we correct? How often did we correctly predict? 4 times. So 4 over 5 equals 80. So 80% is the negative predictive value. All right, and we're going to come back to this spin and snout, but this really is going to help us with ruling in and ruling out a disease. As we talked about before, our goal now is to, with some degree of confidence, say someone either does have a disease or does not have a disease. We can't say it with 100% confidence, as we talked about before, but we want to say with some degree of confidence. And this mnemonic helps us remember that. It says, in a test with high sensitivity, if that test is negative, then we can say that we have ruled out the disease with some confidence. So snout, sensitivity, negative, rule out. And so, of course, a pig has a snout. Okay, now we want to also be confident of ruling in a disease. And so we could say in a test with a high specificity, if it is positive, then we've ruled in a disease. And so sensitivity positive, rule in. I'm sorry, specificity positive, rule in. So see the 2 N's and the 2 P's. That's how you remember it. And of course, he's spinning a basketball. And so snout and spin. And we will talk about that in a subsequent video on how we're going to use that. But again, you can see it here. When we want to get rid of a disease from consideration, when we want to trash it or rule it out, we are really interested in having a high sensitivity. If we want to rule in a disease, meaning we want to treat it, that means we want to have a high specificity in our test. Okay, there was a lot in this video, and I recommend you maybe watch it a couple times or think about it and watch your videos from your EBM curriculum or read some stuff on EBM wherever you are so you can get sensitive and specificity. You're going to do a lot of those table calculations probably in various exam questions. But intuitively grasping this is going to take a while, so don't worry if you don't intuitively get this now. Just keep doing it over and over in your head and try to explain to yourself what these things mean. All right, thank you guys for watching. I appreciate it, and I will see you next time.